You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com. Mystery Spots. My original introduction to the skeptic community came through an unlikely channel. One day my friend John and I were exploring an old abandoned mine in the Mojave Desert called the Gunsight Mine. While deep inside at one point, eating our lunch in a gallery filled with square-set timber bracing, we were struck by the impulse to make an impromptu video, which you can see on the online transcript for this episode at Skeptoid.com. So you're saying that if I pick up some dirt, so if I just grab a handful of the stuff, I can drop it, and you're saying it'll drop up to the ceiling?
Yeah, absolutely. Check it out.
Oh my god!
Whoa,
oh my god!
Look at that.
I don't believe that! Check it out! That is no way, that's the weirdest thing I've ever seen.
Can you see it up there?
Yeah. I dropped a handful of gravel, and it fell up to the ceiling. I called it a gravitational anomaly, and put it up on YouTube. Now, it was an obvious joke, and neither John nor I had any inkling that anybody might take it seriously or think it was real. But take it seriously they did. Smart people began emailing me and asking if there was some magnetic phenomenon or a strong wind in the mine. Someone sent it to Phil Plait, and he posted it on his Bad Astronomy blog. And that's how I originally met Phil. Most people immediately see the gimmick and probably get a kick out of it. Some have their minds blown by the apparent phenomenon, and judging by the comments, some derisively think it was a deliberate attempt to deceive. But everyone has some reaction to it. Wonder, anger, or a good laugh. Without knowing it, I had stumbled upon the reason for the success of the many so-called mystery spots around the world. Some of these apparent gravitational anomalies occur naturally, and some of them are purpose-built as attractions. But everyone either loves them or hates them. Let's point the skeptical eye at what mystery spots are, how they work, and most importantly, why they work. What is it about our brains that wants to interpret things wrong? Typically, commercial mystery spot attractions cobble together a fictional account of how their location was, quote, discovered. The St. Ignace Mystery Spot in Michigan says, in the early 1950s, 3 surveyors stumbled across an area of land where their surveying equipment didn't seem to work properly. No matter how many times they tried to level their tripod, the plumb bob would always be drawn far to the east, even as the level was reading level. The Oregon Vortex claims, the Oregon Vortex goes way back to the time of the Native Americans. Their horses would not come into the affected area, so they wouldn't. The Native Americans called the area the Forbidden Ground, a place to be shunned. The Mystery Spot in Santa Cruz, California says, we noted the compass to vary a small amount on the transit. There was no barbed wire fence near where we were at the time, and as far as we know, no excessive mineral in the ground. We felt very light-headed or top-heavy, felt like something trying to force us off the hill. Like many similar attractions around the world, these mystery spots consist of crazily built wooden cabins built on sharp angles. The range of 18 to 25 degrees off of level is common. Within these structures, any number of conventional optical illusions are constructed and can be performed. A person appears taller who stands under the low end of a tilted beam than a person who stands under the high end. Balls will seem to roll and water will seem to flow uphill. A person can sit in a chair halfway up the wall, supported only by its back legs. It's worth pointing out that there's no such thing as an actual gravity spot, a place where gravity seems to work sideways or otherwise unexpectedly, at least not that a person would ever be able to detect. The whole Earth is, however, scattered with gravity anomalies. Gravity maps show the Earth's surface in color, where the various colors represent the difference between the measured gravity and the gravity predicted from a theoretical reference geoid. We can make these measurements from space using satellites such as ESA's Gravity Field and Steady-State Ocean Circular Explorer, and they can also be made on the ground using accelerometers that are essentially very sensitive scales. The reason the Earth's gravity is not constant is that the density of the Earth's interior varies with different minerals. We use gravity maps for a great variety of applications, looking for oil, salt deposits, potential volcanic activity, even mapping ocean currents. We measure gravity in gals. A gal, named for Galileo Galilei, is a unit of acceleration used in gravimetry and is equivalent to 1 centimeter per second squared. Worldwide, standard gravity at sea level averages out to about 980 gals. This means that the force you feel pulling you into the ground is equivalent to what you'd feel in space if your spaceship was accelerating at 980 centimeters per second per second. If you go higher, further from the Earth's mass, gravity decreases, and gravity at the top of Mount Everest is about 2 gals less. So what about these variations that we measure? Their maximum range is a few hundred milligals, and usually a lot less, way less than normal topographical variance. So if a person is unable to feel the difference in gravity between the ski lodge at the base and the top of a ski lift, you're certainly unable to detect the much more subtle variations that the Earth's maximum natural fluctuations can throw at you. Given this context, it's clear that the gimmicks seen in mystery spots, like a ball rolling uphill or a person standing sideways on a wall, would require a gravity change many orders of magnitude greater than variances on Earth might ever hope to account for. If gravity was actually operating sideways in these parks, there would have to be a dense mass with gravity approximately equivalent to that of the Earth, off to one side, in which case it would be impossible to hide this effect outside the bounds of the park. Whatever's going on inside mystery spots can be conclusively dismissed as having anything to do with gravity. Therefore, the explanation must lie elsewhere. Like all optical illusions, mystery spot tricks work because our brain tries to improperly apply the rules it has learned about the structure of the world. Objects that are farther away appear closer together and smaller. Lines that converge indicate those lines are parallel but receding into the distance. These are just a few of the rules our brains learn as we develop, and they operate at a fundamental level in our perception. So even though we know at an intellectual level that the cabin is merely tilted at an angle, our spatial brains still try to feed us an interpretation that says the water is indeed flowing uphill, and that person is indeed standing on the wall. This perceptual conflict is still enjoyable, no matter how well you know the way it works. Two researchers from the University of California, Berkeley studied the Santa Cruz mystery spot and published their findings in the journal Psychological Science in 1999. In it, they proposed a framework called orientation framing theory to describe how the brain's visual processing is guided by spatial frames of reference. They noted a number of illusions at the mystery spot as examples of familiar tilt-induced illusions, such as the Ponzo illusion, the Zollner illusion, the Poggendorf and Wundt-Hering illusions, and others. No mysterious gravitational effects needed. This theory works not only with the artificially constructed attractions, but with natural mystery spots as well. Gravity Hill in New Paris, Pennsylvania, is one such place, and it's fairly representative of the scores of such hills that are well known. Many of them are named Gravity Hill, Spook Hill, Magnetic Hill, or some similar name. Like most, the Pennsylvania Gravity Hill is a road where, if you put your car into neutral at the bottom, you will roll uphill. Throngs of curious amateur investigators frequent these spots, plumb bobs and surveying equipment in hand, to try and figure out what's going on. Many of these locations have a few things in common. They're often nestled among rolling hills that obscure the horizon, and are away from tall buildings or other structures that may provide a reference plane for the horizontal and vertical. Tree trunks and other natural features are often the only available references, leaving it easy to misjudge the slope of a road that's among hills that are higher at one end of the road than the other. It's the classical optical illusion, again explained by orientation framing theory. Of course, plumb bobs and surveying equipment have their weaknesses. If you think gravity might be acting wrong, a plumb bob is not a reliable tool. Surveying equipment is fine and dandy, but the average layperson doesn't have access to it, or the knowledge and resources to use it properly. But one tool that everyone can get their hands on is a GPS, which operates independently of gravity or magnetism or anything else you think might be going on. Take an altitude reading at each end of a gravity hill, and you'll find that what your eyes told you was the high end is actually the low end. Just keep in mind that GPS units have error ranges, and you'll want to use 2 or 3 different units and let them sit for a good long time at each point to get a good reading. Everyone also has access to good quality radar elevation mapping of the whole planet, Google Earth. And with a little bit of research and a few dollars, you can get a printed topographical map. So far, none of the known gravity hills has been found to actually roll objects uphill once a proper elevation survey is done. The Pennsylvania Gravity Hill has been subjected to many such examinations. One group, called the Enigma Project, published their results online. Their GPS survey found that over the 416-foot length of the road, marked off with start and end painted on the road, it dropped 13 feet, even though to the eye it appeared to rise. They then confirmed these findings using a tripod-mounted surveying laser. Their measurements agree with the commercially available topographic map of the area, and with elevations found on Google Earth. It's fun to experience an illusion, and really mind-blowing to wonder about it when you don't know the cause, whether it's ghosts pushing your car, or a gravitational anomaly lifting you up onto the wall. But for me, the funnest part of mystery spots is comprehending the illusion, and matching what you see to what you know, especially when your brain says you can't. Skeptoid is made possible by financial support from listeners. To see the exclusive material on the DVD-ROM you'll receive for becoming a supporter, come to Skeptoid.com and click on Support Skeptoid. PayPal's recurring micropayments make it really easy and painless for you to make a big difference in helping me to continue producing the show. You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com.